In this video, we will discuss about the circular convolution, or you can say circular or periodic convolution. Circular convolution or periodic convolution is a method for multiplying two periodic discrete time signals equivalent to multiplying their discrete Fourier transform. It involves a wrapping effect, where shifted samples fold back into the signal length and often implemented in DSP to efficiently compute filtering via FFT. What is wrapping effect? The modulo operator ensures indices wrap around treating signal as periodic, which means it cannot be used for linear convolution directly unless zero padding is applied. And you can see the key differences between the circular convolution versus linear convolution. If we have linear, then you can see the resultant length is measured by this formula, or you can say that the number of samples in the convoluted signal is given by this formula m plus n minus 1. There m is the number of sample in signal x of n and n is the number of sample in another signal h of n. So you can use this formula to calculate the resultant number of sample. And here you can see there is a no wrap around. In this circular convolution, you can calculate the number of samples using that formula max m comma n. So whatever the value you have, you can just choose the maximum of m comma n. So it means that you have to have a wraparound effect here in the circular convolution. How can you calculate the circular convolution? You have three different methods. The first method is the matrix method. What is matrix method? Representing one sequence as a circular matrix and multiplying it by the other vector. The second method is the DFT method, taking the DFT of both sequences, multiplying them point by point, and taking the inverse DF. The third method is the concentric circle method, placing one sequence on an outer circle and another on an inner circle, then rotating and summing product. So let's have an example to solve the circular convolution. So in example, x of n is equals to 1, 2, 3, 4. H of n is equals to 1, 1, minus 1, 1. And you need to find the convolution between x of n and h of n. So this is circular convolution. Then you need to use that formula max m comma n in order to see the number of samples in the convoluted signal. M is the number of sample in x of n and n is the number of sample in h of n. In both you have 4 and 4, so that is why its result will be equals to 4. So the solution, again you need to draw a table. So in the table, in the first row you draw x of n, that is 1, 2, 3, 4, and in the first column you draw h of n, and then keep multiplying all the elements of h of n with all the elements of x of n. The first row, if you multiply 1 with all the elements of x of n, that is the first row. Similarly, the second row, if you multiply this element with all the elements of x of n. Similarly, third row, you have all the elements of x of n if you multiply with minus 1. So the resultant will be this one. Similarly, if you multiply 1, again all the elements of x of n, then you have this result here. So then again you need to draw the diagonal lines again here. So all the diagonal lines, and then this diagonal lines, and then this diagonal lines, and then this diagonal lines, and then these diagonal lines. And then you can see what is the max m comma n, so which is equals to 4. So but here you can see what is the yn. The first element will be 1. The second element will be the sum of these two elements, like 2 plus 1, the answer is 3. The third element, sum of these 3. The fourth element will be the sum of all these 3 elements. The fifth element or the fifth sample is the sum of all these elements, and the sixth sample sum of all these elements, and the seventh sample is the sum of this 4 only is here. So you can see the number of sample in a convoluted signal should be 4, but here you can see you have total 7 samples. So it means that you have to wrap around these 3 samples here. So like if you wrap around these 3 samples here, so this 3 1 will be here, 3 minus 1 will be here, and then 4 1 will be here. And then just add them together, like 1 plus 3 is 4, 3 minus 2 is 2, 4 plus 4 is 8, and then 6 as it is. So that will be the resultant signal. Y of n is equals to 4, 2, 8, and 6. So here you see the wrap effect in the circular convolution, and then you can have 4 number of sample in the convoluted signal. So there is another example, like x of n is equals to 1 comma 1 comma 2 comma minus 1, and h of n is 1 2 3 and then minus 1, and then you need to find the convolution between these two signals. And then this time you are using sum by convolution method. Here the first you write the x of n, and then second you will write the h of n, and then take the convolution. So sum by column method you means that you are multiplying all the elements of h of n with all the elements of x of n one by one or point by point, but you need to start from the left side and then keep moving towards the right side. So like here the first step here, then you multiply this one with all the elements of x of 1, and then the second you need to multiply this 2 with all the elements of x of 1. Third, then you need to multiply this 3 with all the elements, and then minus 1 multiply with all the elements, and then you can see the result will be the sum of all the elements. Like 1 will be here, 2 plus 1 is 3, and then you sum together, and then that is the result. Sum together this one, sum together and that one, sum together and this one, and then 1 is as it is. Again here you can see that total number of sample here are 7, but according to this formula for the circular convolution the total number of samples should be 4. So then again you have to perform the wrap effect. So like these 3 sample will be wrapped around on the first locations, like 3 here, and then this minus 5 here, and then this 1 is here, and then add them together, and then 3 plus 1 4 minus 5 plus 3 minus 2 1 7 8, and then 5 as it is, and then you have the resultant. So this is a surprise quiz. So you need to solve all of them together and then find the convolution using both methods, circular sum by column method and the simple method. So you need to apply both the methods and calculate what is the resultant signal, and then give me the answer in the comment section so that we can discuss.